All right, so now we're ready to talk about series. Series are those ones I hinted at before, where we're going to be talking about a string of things from the sequence and trying to add them up. Now, the first ones we're going to try to add up only are going to be the arithmetic ones. We're not, today, you're not going to worry about trying to add up anything in general. It's only the ones where you know you've got, well, like our old friend, the one with the 3, 12, 21, 30. These are the ones where you have a constant adder going on. Oh, I can hear the traffic. All right. So if I wanted to add up a certain number of those, this is how I'm going to do it. Okay. So first of all, that's what a series is. The way you write series is this big capital S. Notice that stands for sum. Stands for series. It does not stand for sequence. Sequence is really just a list of numbers with a comma in between. Series is now, yeah, we're going to actually add up a bunch of those. How do you add all those up? Well, if you were going to add up the first n of a sequence, every single term all the way up to these like 3 plus 12 plus 21 plus 30, realize that each one of those terms can be written like this. The nth term at any point can be written as the first one plus a number of steps of d added onto it. If I want to add all those up, I want to add up, a sub 1 plus a sub 2 where n is 2 plus a sub 3 where n is 3 plus a sub 4 where n is 4. I'm going to get a bunch of things that end up looking like this. The first term, of course, is just a sub 1. The second term is going to be a sub 1 plus the difference. The third term is a sub 1 plus 2 of those differences because it's 3 minus 1 now is 2. Then I get a sub 1 plus 3 differences plus a sub 1 plus 4 differences, yada, 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 until I get to the last one I want to try to add up. And I don't know if you remember this, but when there's an old story about Gauss when he had to do this when he was a little kid. Some teacher gave him detention, and he had to add up the numbers 1 through 500 or something like that. And he did it. And he was like in 6th grade. It's the way the story goes. And in about 5 seconds, he had it all added up, and the teacher's like, "What?" Anyway, his task was to add up all the numbers 1 to 500. Now, this is actually kind of an easier example of what we're going to do in general, but the trick that he got famous for is kind of the same. If you're going to add up all these numbers, that's an 8. If you're going to add up all these numbers, one trick is to go, well, you know what? I know what 500 plus 1 is, the first number plus the last number. I know what 499 plus 2 is because guess what? It's the same as 500 plus 1. 498 plus 3, this is also the same. Each time I add up the first number and the last number from the list, I get 501. And then, if I take those away because I've accounted for them, now it's the new first and last number. It's always going to be the same constant sum. And then I just kind of have to count up how many of these pairs do I have before I get to the middle two numbers. And I take 501 times some number of pairings, and I get it. And that's the basis for how it works. This one, same thing. I had this string of numbers, and I add this up to itself backwards. So I guess it's the same thing as saying, I'm taking 1 plus 2 plus blah, blah, blah. And that equals my sum. Here's one way to write the sum. That's a sum. That's an S. Another way to write the sum is just rewrite it backwards. 500. This is actually how they do it in the book. 500 plus 499 plus 498. Gosh, I cannot write with this thing today. Plus blah, blah, blah. This goes to 500. This goes and has exactly the same number of columns, and it goes to 1. And then you just add that thing to itself, and you're going to get this same kind of 501 idea I was just talking about. You get 501 plus, guess what? 501 plus, guess what? And this ends at, guess what? 501. And now it's a little easier to know how many total 501s do I have. This is 501 times, well, how many columns are there? Well, they're numbered right there, times 500. But when I do all this, this is 2 of the big sums. So the whole answer to this whole problem is 501 times 500, but then I have counted everything twice. And when I added down here, I had 2 versions of the entire sum, so it's actually that. So that's kind of what they're doing here. They say add this thing to itself. Let's just make it backwards. If I add a1 to a1 plus n minus 1d, and then I add a1 plus d to a1 plus n minus 2d, which would be the next one before that, I can add them all up and I find out what 2sn is. If I reduce that, and they do that in the book, and if you reduce that, and it looks kind of like the one I just did, it's n over 2 times the first term plus the last term. The first term for the last term in that example I was just doing was, here's your 501 right here, first term for the last term, which is all fine and dandy if you know what the last term is, but we don't always know the last term. Like if I said add up the first the first 9 elements of that sequence, you'd be like, oh, okay, I don't want to find number 9. You don't have to. You can also use this formula because I know a formula for a sub n. If I put the a sub n, this formula, in for this a sub n, oh, I can make this look a little prettier. If I basically substitute that in for this one right here and simplify it, it becomes this. And this is a little more generic. This is kind of nice. You can use that for your sum of a series. This is your silver bullet for this whole 8-3 section. If you need to know the sum of the first n terms of an arithmetic sequence, it's got to be arithmetic. Let me tell you one more time. This section only works. This rule we're just talking about only works for arithmetic sequences. The first n terms added up is n over 2 times double the first term, and that's just a result of all this simplifying. Double the first term plus this thing you're used to, n minus 1d. At this point, with so much going on, there's really no point in trying to get you to make this reduced or make it prettier, like we were kind of arguing about the first day about this. You could either write this way, or you could write it as like the mx plus b version, where this d is kind of incorporated and simplified. There's really no point to doing that now. This is got so much going on now. I mean, it's got so many ingredients. It's got, if you're going to add up the terms in a series, you got to know a lot of stuff to be able to do that. You got to know what was the first term of this sequence, what was the constant difference, and how many terms you want to add up, and that's where we get these 3 things. So I actually feel like I want to just do one. I did try to clear it up here a little bit, and so I tried to like simplify this, but I don't really think that's very valuable. Let me go ahead and make a sequence, an arithmetic sequence, and let's add up a series of it. All right, so here we go. Let's just do one big ugly problem, and then that'll be it. This video will be kind of short. All right, so what is the sum of the first 15 terms? And another name for first 15 terms, because I want to be careful about my language here. That is where we get the word series. I didn't actually make a mistake by saying sequence. This is a sequence. By summing up a group of them, now we're talking about series. So what is the sum of the first 15 terms of that? Well, in order to do my formula in general, it was S sub n equals n over 2, and yeah, the more times you do this, the easier it gets, times 2a sub 1. It's just a matter of plugging things in. I hate just to plug things in. I like there to just be a meaning behind it, and I think I've given you quite a bit of meaning. But back on this thing, I gave you quite a bit of meaning is where all this stuff came from. But I don't know. It starts to get depressing when it's just memorized formulas and plug numbers in. But that's where I'm at in this video. I'll make a little more substantial discussion of theory when we're in class and I have you in front of me. But anyway, all right. So for this, I need to know a number of things. I need to know. So this is the sum. This S sub n thing, the answer here we're talking about is the sum. N is the number of terms we're going to be adding up, which here is going to be 15. What else is in there? A sub 1. A sub 1 we've talked about a lot. That's first term. And that doesn't mean first term you're going to add up. It's first term of the sequence. And the way this is defined, the only strings of numbers in our series always start from the beginning. It's not like I'm going to ask you to add up the sum of terms number 30 through 40. No, that's not how this works. It's always going to start from the beginning and string up from there, which makes life a little bit easier. And the other ingredients in here, I already got n. N kind of shows up in 2 places, which bothers me a little bit. I don't know about you. Does this make you dizzy? Okay. And then the last thing that goes in here is d. This is better than evacfa, right? D was the constant difference, which here, if you are astute enough to be looking in the right places, it's the difference. It's what you'd be adding as you go from term to term here. We did that a lot last class. The constant difference here is something like 11. Okay. I'm writing slowly because the pen is lagging. All right. So in this particular problem, that means we're talking about the sum of the first 15 terms. And I can put a 15 there because that's the 15th thing. I want to add up 15 things. It's going to be n over 2 times 2 times a sub 1 plus, sometimes when you do these things, it's hard to know what stays variable and what you can substitute in. Here I'm actually asking for a number. What is the sum? So at the end of the day, you can get an answer for all of this. Because you've got all the information here to actually add up 15 numbers. I really don't want to do that by hand, so that's what the formula is for. Okay, n minus 1 times the constant difference, which is 11. Okay, it looks like calculator time at this point, or just about calculator time. This is 15 halves times, well, I guess there's a little bit I can do by mental math here. 14 times 11, yeah, okay. Calculator city. Bam! So I did that on the calculator, and I got this. I got 1,245. And that is that. Hopefully that seems sort of reasonable, that if I'm adding 15 numbers to this, first of all, once I get to the 15th number down here, it's going to be a pretty big number on its own. I'm adding that plus all the ones before it. They all add up together to be 1245. Hope you enjoyed. I made this a little shorter than normal, and I am trying to talk slower. Hopefully I've reached that target. See you at the do now.